My name is Kirk Eaton, and I will be sharing this presentation with Ms. Shauna Burnett about the rabies virus. My portion will include classification, history, anatomy, as well as living requirements for this virus. Now, the classification, since it is a virus, this one does not have a domain, a phylum, or a class. So we say that the kingdom that it is in is virus. We say the order is Mononegovirae, and the family is Rhabdoviridae, and the genus is Lysovirus. All right. Now I've included this picture. I couldn't find a picture of the classification list, but I found a picture representing the cell itself, and you can see a little cross section, and you can see the spiral that this ribonucleoproteins make, and I'll get to that when we get to structure. Now, a little bit of history. The first signs of this virus was actually seen in Egypt. I think it said around 700 BCE, but I don't have any information from then until the 1960s. Now, before the 1960s, there is around 100 cases a year of people in the United States dying because of this virus. And so it was carried by domestic animals such as dogs, cats, squirrels, what have you. Well, after the 1960s, when animal control became a serious issue, the amount of deaths just decreased rapidly. And so what happened was it went from 100 deaths a year from the 1960s to in the 1990s, one or two cases a year until today and through today, where it's only one or two cases a year of people in America dying from this virus. Now, where does this, so that's about the USA, but where is it prominent? It's really prominent in developing countries where their health systems aren't as good, and there's almost no rabies surveillance at all. They're not looking out for it because they can't. They have to put their time and money towards other issues such as public safety or what have you. So now I want to get to the anatomy of it. And now I say bite the bullet because to me it looks like a bullet. It's a half capsule virus, and it has these structures called the helical ribonucleoprotein core, which basically it surrounds the inner side of the nuclear envelope, or not nuclear envelope, but the envelope, where it just circles around, and when it gets to the tip, it closes in. All right. Now, in that helical ribonucleoprotein, there's RNA just tightly packed within that, and that's what they use to replicate. Now, it is only 180 nanometers long and 75 nanometers in diameter. And let me see, it has these little prongs that stick out called trimetric spikes. There's around 300 or 400 depending on the size of the virus, and so on. Now, the living requirements is, I say it's a mesothyle because it's in most mammals where their body temperature lies between 35 and 38, I think, degrees Celsius. Now, I put that the nutrient needs a host cell for replication, but I put blood cells, but I couldn't actually find that on the internet. That'll be explained more in depth when we get to replication in the slides by Shauna. So it needs that host cell to replicate. Now, with the oxygen, since it's a virus, it doesn't need oxygen, it really just needs a host cell. But I put in there that doctors especially have to watch out for their patients with the rabies virus in them. They have to watch their oxygen levels, unless they'll just deplete. And once that happens, they'll lose blood to their vital organs, their extremities, and so on and so forth. So doctors really have to pay attention to that kind of thing. So that's it of my portion. Thank you, and good luck on the test. Go ahead.